So our next objective, describe stratified sampling, cluster sampling, systematic sampling, and voluntary response sampling. So these are different sampling techniques that are trying to be random. So it's not quite simply random though. So there's pros and cons to all of these, which we're going to kind of touch on here a little bit. So we're going to start with stratified and cluster because they're going to sound like they're the same, and I guarantee that they're not. We're going to talk about how they're not. So in a stratified random sampling, the population is divided into groups called strata. Then a simple random sample is drawn from each stratum. So I have a little picture on here to kind of show you. So we have like incomes. We have low income families, middle income families, high income families. So if we were doing something we think is going to have an effect on income, or income's going to have an effect on it, like let's say polling. We expect there is data that shows that your income level and your political values are kind of aligned in a way. So if you were to, want to do a poll and kind of see who, people are voting for, one of the things you might want to do is make sure that you want to get people in your group who are low income, middle income, and high income. So it's that way to ensure that it's representative because I'm showing all those different subgroups. And then what I do is I'd randomly sample from each group. So from low income, we just randomly sample 2 households. We randomly sample 3 from this one. We randomly sample 2 more from this one. So that is what a stratified sample is that we're going to split the population based on some sort of identifier about the population. So in this case, we're using their income as an identifier. So stratified sampling is useful when the strata differ from one another, but the individuals within the stratum tend to be alike. So like we said, so the stratums are different to each other. Low income may be more likely to vote for we'll say they're like green and purple party. Maybe low income income's more likely to vote for the purple party. High income's more likely to vote for the green party. Maybe the people in the middle, they're more likely to, who knows, maybe they're more likely to vote green too. Who knows? But the fact is that we want to try to get something that's very representative of what's going on. Maybe they're greenish. They lean that way, but they're not really that way, So there's going to be something different about each one of these groups. So we want to make sure we sample from each one of them. So they are different income levels, but the people in that income level tend to be alike in a lot of other ways. So just another example, say a company has 800 full-time employees and 200 part-time employees. So if they wanted to sample their employees to ask them, like how they feel about working there or anything like that, they would draw a sample from both groups. So in this case, they draw a sample of 100 employees, and it's going to be simply random of 80 employees who are full-time and 20 employees who are part-time. So you had your 2 groups because there's going to be something different, like their job satisfaction working full-time and part-time are completely different from each other. If you ever work someplace where you have a lot of part-time employees, you will see, or full-time and part-time, you notice that their levels of fulfillment are definitely different from each other. So if that was something you were looking for, yeah, you'd want to split your employees by full-time and part-time and then sample from both of them. Okay, so a drug company wants to understand the effectiveness of a new weight loss drug on the population. Sorry, that was a typo there. How could we use stratified sampling to collect a sample for the study? What groups or strata could we use to divide the population? So take a moment to think about that. So if you wanted to test weight loss and you wanted to split your population in groups, what are things that you think might have an effect on weight loss? So one of the things that definitely we know has an effect on weight loss is your sex. There's a lot of things with medication, stuff like that sex definitely affects. Being male or female will have a definite impact on how that medication will behave. And it has a definite impact on how your bodies just respond to anything in general. Women tend to hold on more weight than men. So we're pretty sure if we're testing weight loss, well, one of the things we'd want to do is make sure we have both men and women in our sample. So that is one way that we could split up this, stratify the group. Age groups would be another one. You might want to look at different age groups to see the effects. Health conditions, you may want to split people based on health conditions like diabetes and pre-diabetes. So there's other ways you can do this. We're just going to use male and female because that's two of them and it's quick and easy. So we can use a stratified sample. Sorry, we're going to stratify our two stratas into male and female. Like I said, there's many of them. So if you came up with something different, that's okay. So what we could do here is that, let's say we would just sample 50 men here. And then we would sample 50 of the females here. And what we would do is that and we would randomly sample. So I would randomly sample. Randomly sample 50 men and 50 women. And I would do it probably like 50-50s because men and women, it varies as you age, but generally they're very equal to each other. You actually initially start out with more men than women, and then as the groups age, then it sort of adjusts and there's more women in the end. Okay. So that's one way you can do it. There's other ways. It didn't have to be 50 one group, 50 other. It's just I just try to keep it even. Cluster sampling is a little different. It's going to sound kind of the same, but just slightly different. So in a cluster sampling, items are drawn from the population in groups or clusters at random. So we are drawing groups out. We're not breaking up the groups in random and sampling from the groups. We are pulling out whole groups. So we are sampling whole groups here. So cluster sampling is useful when the population is too large or spread out for a simple random sample to be feasible. So that's kind of like what the mall one was trying to do. The population spread all over the place. It was just easier to go one destination sample. Doesn't mean it was the best way to do it though. So an example is like, let's say we have this county here and it's broken up by its time code zones. So what we would do is we would just sample instead of the entire county. We might just sample zone 1 only. So that is what a cluster sample is. So you might be noticing there's a little difference here. So with a stratified, I broke up the population based on some sort of identifier, like were they full-time, were they part-time, what were their genders, what were their income levels. This we're breaking up really by geography. So what zone are you in? And with stratified, what we did is we randomly sampled from each one of our groups. Here in cluster, we sample a whole group, or we might sample 2 whole groups. So to estimate the unemployment rate in a state, a government agency draws a simple random sample of households in 3 counties. Someone visits each household and asks them how many adults live in the household and how many of them are unemployed. What are the clusters and why is this a cluster sample? Well, first there's clusters, that's partly why. So we have some sort of state here. So just let's randomly pick a state. Yeah, that's good enough. That's a random state. Someone visits each household in 3 counties. So what we're doing is we're just picking a couple counties. So what we have here is my clusters are counties. that we have in the state. We want to know, why is this a cluster sample? Because we sample whole counties. We're not taking a random sample from each county, we're sampling whole counties. We might not sample every county, but we are taking whole counties and looking at them. So I add this in here, stratified versus cluster, because like I said, they sound the same. Stratified sampling divides a sample into groups, which are strata, we're calling for sample by, and sample, not samples, we sample from each group. So each one of our groups, we take a sample from. So we just take a little portion of it. When we're doing a cluster, we divide the samples into groups we call clusters, and we collect all data on all members of a few of the groups. So it's kind of the same way. We're going to have different groups, but this time I'm not sampling a little bit from each group. I'm just taking two whole groups and sampling them. Those probably vary a little bit. And they do have an impact on the kind of data that we get. A stratified sample is probably a little bit better because we're getting something random. But cluster, it's random, but we're randomly sampling whole areas, and there could be differences between those whole areas. Stratified sampling also usually divides the population by a category, such as age ranges, gender, religion, race, income levels, things like that we use to divide the population. Cluster sample usually divides a population by their location. So we split a county by townships and we just select townships. Or in that one case, we broke it up by zones and we select certain zones. If you're looking at a town, you might just go to certain streets. If you were sampling at a school, you might just hit like 3 different classrooms and just talk to everybody in that classroom. So cluster is usually more location based when you're breaking up your population. That word just will not come out. Okay, cluster sampling. So cluster, oh, this is just another example of cluster sampling. The clusters, where was I? The clusters are the groups of adults in each of the households in the county. So this is a cluster sample because it is a simple random sample of clusters. Okay, this is a random sample because simply random samples of clusters is selected. So what we're saying here is that these are all my clusters, but I'm randomly selecting some of those clusters. So there's still a randomness to your sampling. And I think I had a slide out of order here. And every individual is going to be selected. So there's still that random part to it. So with stratified, you randomly sampled from each group. Cluster, you randomly sample cluster. So systematic sampling is when you sample every nth item that you have coming towards you. So this would be like if you had a line of cars, you might select every nth car. Or if you were having people come into a business, you might like ask a question or poll every 5th person that came into the store, something like that. So it's something systematic. So you keep it always that same number. Systematic sampling is sometimes used to order products as sometimes used to sample products as they come off an assembly line in order to check that they meet quality standards. So this is a common thing, like you might sample every 20th item. So my family worked for GM for years, and that was one of the things they do is there was a few cars, like I can't remember how far it was, but every so many cars they would sample and they would have to take them off the line and to test them out, make sure everything was working, to make sure that everything on the assembly line was working correctly. Because there was something wrong with those cars, and they had to worry about all the cars that came off the line that night. So it's a pretty common technique. So as an example here, automobiles are coming off an assembly line, A systematic sample will be drawn from a detailed, for a detailed check. So like I said, just like with the cars. The starting point will be the third car. So we don't always have to start at the first. So we're saying we're starting at the third car. And then every fifth car after that will be sampled. Which cars are going to be sampled? It's pretty easy, like I said. So you don't always start as the first car. So we're going to start at third car, and then we're going to sample every car after that. So we got the third, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we get the third car. 2, 3, 4, 5, 6, 8 cars, right? 8, 9, 10, 11, 12, 13 cars. And then the next one would be you'd have 14, 15, 16, 17, 18th car to be selected. So as you see, if we start building all this, we got a pattern here. So we'd go 3rd, 8th, 13th, 18th. And then my guess next would be 23rd, because that's the next 5 cars away. And then we'd have 28 cars. Then we'd have the 33rd car. Then we'd have the 38th car. So that would be all the cars that we would sample. So it is random. There could be a few little problems with that, like if something's sorry, something is just itching. It is sampling is probably a good way to sample things because it is fairly randomized. It's just, once again, not everything has an equal chance of being selected because, in this case, it's every 5th car. So just as like a figure, just as a way to kind of compare the different methods. So you got your simple random sampling. So that is just, the sampling just comes from everywhere. We got a randomized group of people and just randomly pulling some of them. Systematic. So in this case, we pick this person first, and then every 3rd person gets picked. So we go 1, 2, 3, this person, 1, 2, 3, this person, 1, 2, 3, this person. Simply random. Oh, sorry, not simply random, stratified. So now we split these people up by their shirt colors or their outfit colors. And then we just randomly select some people out of each group. So in each case, we're just taking 2 people out of each group. Systematic, once again, if they split up by their shirt color, but this time we're just only sampling 2 of those shirt colors or outfit colors. But it was just a nice visualization to how this is actually working. So identifying sampling techniques. We do have one more to talk about, but we'll just get through these ones first. Identify the kind of sampling that is being used. So a drug trial needs a control and treatment group. Age was a factor to control, so the population was divided into groups. And then we should probably put in here, and then there was a sampling from each group. Something that was kind of assumed here. This was an older problem I used to have. The DMV wanted to discover the percentage of visually impaired drivers on the road. They required every 7th person renewing their license to go through an eye exam. The local newspaper wanted to poll the public about their opinion on Proposal 3. They interviewed locals who came to the park on weekends. So what kind of sampling technique is this? You might have to think back. This is a little older one. So I don't have all my techniques in here, but a local DNR wants to establish the size of mosquito population. The department divides the county into townships and gathers data on 5 of the townships. So we only look at 5 of them. So we're going to skip A and D for right now because those ones are a little more complicated ones. So B, that's the easiest. We're picking every 7th item. This is systematic. All right, so then if we go back to like A and B, or A and D, sorry. So this one is, we split the groups by ages, into ages. and then we sampled from each group. Here we broke up the we broke up the county by townships, and then we only sampled 5 of them. So when you sample from each one of your groups, this one is stratified. Also, we broke everybody up by some sort of identifier about their about age and things like that, so not location. D, we broke everything up by location, and then we sampled only from some locations. So we took whole counties there. That's a cluster. And then this one. So this one's not simply random. So we went to the park and interviewed people. So this would be your convenience. Okay, so our last one to talk about is voluntary response sampling. So voluntary response sampling, often used by the media to try to engage the audience. So this is when they ask you to call in to give your opinion, or, that used to be call in. Now you just send them a message. But anyways, for example, a radio announcer will invite people to call the station to talk about what they think. Voluntary response samplings are never reliable for the following reasons. People who volunteer an opinion often have a strong opinion that is typical of their population. So if you were doing a poll, like if it was Fox News or CNN, they're going to get strong opinions towards the populations that are their demographics. So, Fox News tends to be more identifies more of your conservative population. CNN tends to be identifies more of your liberal population. So they're more likely to have very strong opinions that are typical for that population. So if Fox News or CNN asked a poll about abortion, they're going to get 2 widely different opinions on it, because it's going to be those really strong opinions that are typical for those populations. People with negative opinions often are more likely to volunteer the response as well. So when you have a bad experience at a restaurant, so when you have things like when you can volunteer to review a restaurant, say like on Yelp, that is also a volunteer response. And usually what happens is people, when they have a bad experience, like to get on Yelp and just complain. So also this happens with good experiences too. When you have really good experiences, you're more likely to report those as well, but definitely negative experiences are more likely to be reported. And if you think about things like when you bought stuff off Amazon, oftentimes when you probably reviewed it, it's because something didn't go well. It broke right away or something like that. You didn't usually leave a review of the item if it was okay and it just worked the way it was supposed to. So usually strong negative opinions tend to get recorded as well. So it gets very biased. And what we mean by biased is that it doesn't reflect the actual population. It kind of gets pulled one way or the other from the opinions of the actual population. All right, so we want to identify our sample. A radio show host invites listeners to send an email to express their opinion on an upcoming election. More than 10,000 emails were received. What kind of sample is this? Why would this sample not be representative? I think it's clear that this is going to be voluntary. Or voluntary response sample. Because they send out they're asking people to give their opinions. They are invited to. So when you're invited, it's voluntary. So it's a voluntary response sample. So that's the kind of sample we do have. Why would this sample not be representative? Well, for one thing, you're only going to get opinions of the people who listen to the show. So only listeners are going to respond. So that's one of the problems that you're going to have here. Listeners send an email. I'm just reading to see if I messed something here. So when you're going to give your opinions of this election, what you're going to, like I said, you're mostly going to get listeners who are going to respond, and probably not only that, probably more dedicated listeners are going to respond. So your information is going to be swayed towards that listening group that you have. So if your listeners are more conservative, your data is going to be more conservative. Your data will reflect more conservative opinions, which maybe that's what you're aiming for. But if you're like, just want to know what people are thinking, and you ask people to call into your show, you're going to get just your viewers calling in, and they're listening to you because they like what you say, and it goes along with what they say. Data will be more conservative. So yeah, like I said, this has caused the problem because really it's the people who are going to be engaging with that program, the ones who are going to give their opinions. So like I said, it's going to be very strong towards whatever group of people tend to listen to that program. Like I said, so if it was a more conservative program, the data reflect more conservative values. And when people are calling in to express their opinions about an election, they're probably going to more likely say they vote for the Republican candidate. Okay. And I lost the objective for this one. So this one, the objectives has to do with identifying what is called a parameter in a statistic.